Okay, let's start the session. Today we'll be going through usage of traveling microscope. Okay, so as usual, like in the past 4 days, we have to go through purpose, material, theory, procedure, and what you call special points to be considered when doing this experiment. Now, what is the purpose of this experiment? One, to find the internal diameter of a capillary tube, and also to find the diameter of flexible objects. Okay. And there's one more thing. I thought of today to include the finding the refractive index of a glass block. That experiment also into this, because if you go through an old paper, any paper, we don't have. Whenever we get a traveling microscope question, and at the end, at the last few questions are from finding refractive index of a glass block. So I thought, let's do all of those together in one single tube or one single day. It doesn't take that much time. So materials. We need a traveling microscope, capillary tube, rubber wire, and the glass block. Otherwise, there's one more thing we need in order to use the traveling microscope. What is it? It is a certain thing. What is it? Chat එක දාන්න බලන්න. Oh. Stand. You can stand on it. It has 4 legs. හරි. මත්තක නෑ මං හිතන්නේ we need a meter ruler. Why do we need a not meter ruler? Or a spirit level. Yes, we need spirit level. Why do we need a spirit level? To level the traveling microscope. Okay. Then that's it for materials. Let's go for the theory. As usual, like in the vernier caliper, we have a vernier scale and main scale in it. Okay. Before that, let's go through the parts needed. Okay. What is this called? I should make the black and blue. What is this called? This is called a what do you call it? Horizontal main scale. And here we have horizontal vernier scale. Here we have vertical main scale. Here we have vertical vernier scale. Other than that, we have 2 knobs here. What are these knobs? Commonly called. They are called. What are these knobs called? There's a special name for those knobs. Yes, they are. For a horizontal one, you call it horizontal blank. No. What is that knob called? Adjustment name, fine adjustment knob. Okay, because this knob makes fine adjustments. Again, it will make adjustments like in this scale of 0.01. Okay, when we remove the lock screw and when we push it here and there will be huge difference. Yes, fine adjustment knob. But these knobs, they can control your what you call movement up to 0.01 millimeters. The least count of the traveling microscope. So this is the horizontal, vertical may find one now. Then this is called a microscope. For this, we have a focusing knob. Thereafter, what else can we have? On this, on the corners of this, there will be a two screws at each end. What are those screws? Those are leveling screws. Okay. Why do we use them? To make the traveling screw microscope level. You know what I mean. Also, um, we have a lock screw here. We have a locking screw here and a locking screw here. Why do we have so when we take measurements, a large measurement, we have to remove the lock screw and move the entire what you call arm to a desired position and then lock it again. That's how we normally do the experiment. Um, Otherwise, other than that, in a microscope, we have two pieces. This is the microscope, and this is the microscope. In a microscope, we have two pieces. One is the eyepiece, we don't think about it, and inside this we have cross wires. Before starting any experiment, we have to move the eyepiece such that the cross wires are focused. So that's it for the parts of this instrument. Least count, you know it, same as vernier caliper, the same principle as vernier caliper. You have to divide the number of length of main scale division by number of vernier scale division. We have two types of traveling microscope. One, we get 0.05 millimeter divided by 50. And there's another one where we get 1 millimeter divided by 100. Which one is more common when it comes to vernier caliper? No, sorry, traveling microscope. Which of these is more common? Which of these is more common? Takkara daan thinking. Test එකට දාන්න කට්ටිය නැද්ද නිදිද? If you have it, what do you call put a heart reaction? ඉන්නවා. අවුලක් නැහැ. Yes, fine. We have this circuit. This is going to be sometimes you get a range extended traveling microscope. Range extended vernier scale for the measurement data, there's a much more expensive traveling microscope than this. Okay, so normally nowadays we have this. Now physics labs. Yes, we have this one. Okay, we don't have this one. So we have to remember that. Other than that, there's not much of a theory. Okay, then let's go through procedure. Okay, first of all, in the traveling microscope, we have to first find the least count. Okay, as usual, as every single experiment we do, every single measuring instrument experiment we do, you have to first find the least count. Least count is always in a traveling microscope, always the least count is 0.01 millimeters. Next, we have to use a spirit level and adjust the leveling screws and level the platform of the traveling microscope. Again, we have to keep the spirit level here. And then we have a small bubble here, and bubble can one. Okay, so we have to level it. After that, okay, okay, I didn't mention that. After that, and I mentioned it earlier. When you use an eyepiece, after that, you have to focus on something far away, and then we have to change the eyepiece such that, move the eyepiece such that the cross wires are focused. Okay. Then normally, then we remove the rock screw and make it horizontal. Why do we make it horizontal? Calculative may you can't keep the calculative on this table and do the and find the measurement. So we have to make it horizontal. Okay, horizontal karla. Okay, we take another stand and fix the calculative coaxially with the microscope on a stand and focus on its face. Calculative face එකක් තියෙනවා මේ face එකට focus කරනවා. How do you focus? Using the focusing knob. Thereafter, we have to take horizontal measurements and vertical measurement. How do you take for horizontal measurement? We first take the measurement of this side. Name crosswise in the measurement area. Thereafter, after this, we have to take the measurement like this. Color crosswise like this. Either way, let's say this is x1, this is x2. You have to find the difference between them. Okay. Same way for horizontal. What do we do? For horizontal measurement, sorry, these are horizontal measurements. For vertical measurements, we keep the crosswise as such. Name it. Okay. Here we take y1 value and y2 value. Okay. So this is going to give the horizontal reading. This is going to give the vertical reading. Okay. Thereby, we can use this find an average for the mean internal diameter of a capillary tube. Do you have any questions in that? There's one more thing. X1 is 2, y1, y2 is let's say you have taken x1 reading. To go to x2 reading, which way should the arm move? Left or right? Check it down. Left. Because what is happening is, let's say we draw the what you call microscope. We have the objective piece and the eyepiece. Okay. In the objective piece, we are seeing the no. Maybe you go. Maybe we have something like this, and then we are seeing this place. We are seeing this place in such a way that we have the capillary what you call internal diameter මේව තියෙනවා කියලා කිව්වොත් we are seeing the image inverted. Okay නේද? We are seeing the image inverted. Okay. Therefore, after we take the left side measurement to go no here left side measurement තියෙන්නේ කවුද? මෙයා. මෙතන right side measurement තියෙන්නේ කවුද? මෙයා. It is inverted. So, in order to move right, you have to actually move the arm or the microscope left. Okay, neither. I hope that one person is clear. Not one person. Tao goda cutting Indian. Right here, tao cutting. In hitna cutting. So that's how we measure. Okay. What else? Okay, so that is how you measure the internal diameter of capillary tube. Do you have any doubts? If you don't have any doubt, let's see what reactions do we have. Thumbs up reaction එක දාන්න ඕන. No doubts නේ. No doubt. Question no doubts නේ. Okay. That is for capital Q. Now let's say we have a flexible hose. We have flexible hose. We have flexible hose. Flexible hose in we have outer diameter and an inner diameter. Okay. So I am not going to be drawing 8 drawings here. I'm just going to explain how to measure. Okay. First of all, to take the measurement, we take x1, x2, y1, y2. Find the difference, add up and find the mean internal diameter like previously. Okay. That is for, yeah, that is, yeah. Internal mean, what do you call? Internal diameter of a rubber tube. Next, what do we do? We have to find the outer diameter. Outer diameter means we will get x3 here, x4 here, x3, x4, uh, y3 here, and y4 here. Okay? And then we have to find the difference between these two, and find the average. Okay? Then we can find the what do you call external diameter of the rubber tube. And then using this, you can do two things. One, find the thickness of the tube. Another thing, what can we do? What else can we do? If we are using a small piece and you know the mass of the piece, we can find the density. Okay, capital T density where make it you can find the density of the rubber tube. Okay, per length mass per unit length වගේ ඒවා ගන්න පුළුවන් rubber tube එකේ. What else do we have? Yeah. So we are done with this. When we hold a rubber tube now, මේවනේ capital tube we held it in a stand. Stand එකේ මෙම ඇල්ලුවාම capital tube will stay. You don't have to, it doesn't break. Rubber tube, can you hold it like that? No. Then what can we do? What can we do to hang a rubber tube? What can we do to hang a rubber tube? Tie it in a rope. ගැට ගන්නකොටත් මේ when you are tying it towards it can get squeezed නේ. This is a rubber tube. What we normally do is හරිද? We take a iron rod. Okay, iron rod or any rod of different color than the rubber. Again, rubber කළු පාටයි නම් you cannot use a black color rod. We have to use something else. Okay, and we hang it on a rod. මෙහෙම hang කරනවා. Okay. Or you okay, either this or either you hang like this or you get two rods and hang it here. මෙහෙම තියාගන්නවා. මෙහෙම තියලා මෙහෙ කරන්න ඕනේ. Okay නේ? That was also a point. That was not much discussed. මම කරනකොට discuss කරපු නැති point එක rubber tube එකේ දැන් you cannot hold a rubber tube with the stand නේ. එවනම් කොහොමද ගන්න කියලා අපිට දන්නේ නැති පිළිකයක් තිබුණා. But in the resource book, in the resource book, you can hang it in a rod. Okay, but you have to make sure that the color of the rod and color of the rubber tube is same. Then, yeah, make sure that the color of the rod and rubber tube is not same. If it is same, what will happen? You cannot get X2 and Y2 and Y2 and now. So you have to make sure those two are completely different colors and you can figure it out. Iron rod meaning glass rod color. You know why? Glass rod will reflect, not reflect, refract light. एक heavy two in here. Two in here. Two in here. मेरा बैग two in here. Oh, एक दन्ना two in here. In a two-way mirror, it depends, okay? It depends on the question they ask. Normally, a two-way mirror will have two-way mirror is like two-way mirror is something else, okay? It's not actually a mirror. It's a really good material that gives proper partial reflection, okay? It is not actually a mirror. That's why we can say yes කියලා but මේක අහන්නේ මේක this is over the limit. Okay, he was asking something about the speedometer. Let's go with this one. What do you call traveling microphone? Next we have so we can find the what do you call? We can find the what do you call? Yeah, we have found the internal diameter of capillary tube, external and internal diameter of a No, no, no. This is not the telescope you get in spectrometer, okay? This is a microscope. In spectrometer, we get telescope. Those two does two different things. Okay? This will, this will මෙතන object එකක් තියෙනකොට this will enlarge it and send it out. What does the spectrometer telescope do? It takes an object from infinity and bring it towards what do you call? Convert it to the here also we have crosswire. In both devices we have crosswire. The reason is we have to aim somewhere. You understand? Then you have to aim this crosswire here in this. Maybe aim කරන්න පුළුවන් නම් තමයි you can get a measurement. Same thing in what you call spectrometer. There are what you call light slit එක තියෙනවනේ. The slit should be aimed to the center. To aim කරන්න තමයි we have the crosswires. Okay, but other than that, this is a microscope, that is a telescope. Those two are two different things. Okay, fine. That's also a good question because some people don't know this is a microscope කියලා. Traveling microscope කියලා කියන්නේ අරකටයි telescope අරකටයි spectrometer එකේ adjusting the telescope කියලා නෙන්නේ adjusting the microscope කියලා ඉන්නේ නැහැ. ඒක some people don't know. Even this close to the exam, some people don't know. ඒක ඉතින් current you have to if you have experienced it, you would know. Otherwise අර පොඩි doubt එකක් තියෙනවා. නැත්නම් someone should teach. That's a small point. Anyhow, then we are finding the refractive index of a glass. Okay, this is actually a completely different experiment. But if we ever check past papers, we have a traveling microscope like for 20 marks, 10 marks is traveling microscope. Okay, another 10 marks is from what we call refractive index of a glass. And these two normally come together. That's why I have added it here. When measuring so basically we know how to now. I think there's no doubt in finding the measurement in a traveling microscope. Before I go to glass block, finding the refractive index of a glass block. No doubts, Nate? Okay, I hope there are no doubts. Yes. We have a glass block. Okay. In this glass block, let's say we have an object here. And then there will be image here. And then this is the thickness of the glass. Okay. This we call apparent depth. Yes, this is called apparent depth. This is called real depth. Okay. So we have to find three values such that we get an apparent depth and real depth. Okay. That is making me tan theta cos theta in structure paper again. Maybe it will come in light question. Otherwise, they won't ask in the structure paper. So anyhow, you know this name. N is equal to real depth over apparent depth. Okay, refracting index of a material is based on real depth and apparent depth. Okay. In this experiment only, we are the what do you call external medium is air. If not, we cannot do this. We cannot use a traveling microscope. Okay. Then we are using glass block, so it is G. Okay. So refractive index of glass respective to air can be found by thickness over apparent depth, image depth. Okay. So what do we do first? Okay. First of all, we place a paper with a cross mark on it. Okay. And then bring the traveling microscope to this point and then focus the traveling microscope on it. Okay. When you're doing that, what do you normally do? What we normally do is we bring, first of all, we bring the, what do you call, we make the microscope horizontal and focusing object in a place such that it is somewhere in the middle, okay? Again, it is not at the maximum or minimum, somewhere at the middle, okay? And then we open the top screw and then we push it down, okay? We first push it down and then at a certain place, you will start seeing the cross, okay? In all other places, you won't see the cross. At certain place, at a certain distance, you will start seeing the cross. At that point, you block it and then you use the focusing knob to focus on the cross. Okay, Neil? And then we take the first reading. This reading will be taken as X. Okay, Neil? That's the first reading. Okay. Then is first reading called A, B, C. Where it is? Where is the first reading? අපි ගන්න first reading for which one? පොඩි දෙයක් නේද? It is for, yes, it is for A. Okay. Then we have taken the reading for A. Okay. Now we are keeping the glass block for A. Okay. We are keeping the glass block for A. Okay. And then we have to move, okay. There are few ways of moving, okay. If this glass block is around 3 or 4 centimeters, it's greater than 2 centimeter thick, okay. What we do is normally, we remove the lock screw completely and then move the telescope up until again you see some sort of image of X. And then you lock the screw and then you use the fine adjustment to get the next reading to again get the clear focus. Then after you got the clear focus, you find the vernier, you match the vernier coinciding division of vernier scale and all the stuff and finding the length Y. Y is going to be, Y is going to be B. Okay. Thereafter, we use lycopodium powder. Now, why do we use lycopodium powder? Why do we use a lycopodium powder? There was a question like that as well. Why do we use the lycopodium powder instead of any other material? Because the particles of the powder, the particles of the lycopodium powder is really small. Okay, it is really small. So therefore, the increment in height or thickness due to the lycopodium powder will be negligible. Therefore, we use lycopodium powder. Okay. Then we put lycopodium powder on top of the glass block And then finally, same way, remove the lock screw, move it up until you see some sort of image, lock it, and then you use the final adjustment to get the final reading there. This is going to be C. Okay, that's one more thing. After this reading, after you have taken X, okay, you are not gonna touch the focusing knob. Okay, you are not gonna touch the focusing knob. You will be entirely moving this vertical, all this full component with the vertical vernier scale. Okay, neda? And then we can write this one. Then it will be real depth is going to be sorry. It's going to be more good minus 3, minus 5. Okay, ne? So that's how you find the refractive index of a glass block. That's one more thing. No, let's go to the special points and then figure that out. Up to now, do we have any doubts? May refractive index of a glass block, we have some, I mean, it's a short lesson, but you might have some doubts, Nick. What are doubts do you have? If you have no doubts, Alright. If you have no doubts, raise your hand. Make it a raise your hand. Six. There are no doubts near for others. After what measurement we should change the focus? No. Maybe. First you change the focusing knob to get X. Okay, first you change the focusing knob to get the X value. Okay. After that you are never changing it. You are never changing the focusing knob. Okay, Neil? That's a higher percentage because same as speedometer, we have only same as speedometer, we have one speedometer, we have only one question from this in past paper. Past paper එක ප්‍රශ්නයයි තියෙන්නේ. Okay, that I have included in this tute. Okay, that is the only question we have in a past paper. So, and that came in 2018. Okay, so we cannot say what will happen. There's chance for this. Anyhow, there's a chance you will get measuring instrument. We don't know which one, but there is a really high chance you're going to get a measuring instrument. Okay, then shall we go through the special ones? Okay, when we take measurements vertically, horizontally, we have to calculate the mean value. This will reduce the random errors of this experiment. Now, method and mean value where you cannot take three measurements, 3 or 4 measurements in like in all other experiments. We only have 2 measurements, vertical measurement and horizontal measurement. So we are using vertical and horizontal measurement, those 2 measurements to find the mean value. Next, it is crucial to fix experimental tubes coaxially with the microscope to ensure that the sharp focus and accurate phosphorus are. When you are, this is the microscope. Okay, this is the microscope. This is the microscope and this is the microscope and this is the capillary tube. Okay, when you place this capillary tube, they should be perfectly coaxial. Okay. මේව චුට්ටක් තිබ්බනම් what will happen? Full එකම glass පේනවා. It will become dark and there are so many other issues as well. Okay. So they have to be perfectly coaxial. What do you call the microscope and the instrument you are measuring? Okay, Nick? That's one thing you have to focus. තව දෙයක් තියෙනවා. Okay. If it is coaxial, if it is not coaxial, okay. Yeah, this is, if it is not coaxial, name it in, let's say this is the internal diameter of a capillary tube. හරිද? There will be dark regions like this, okay? මේව dark regions තියෙනවා. හරිද? මේව dark regions තියෙනකොට this will first of all look like an oval. Okay? Second thing, when you take a measurement, ඔයාගේ x1 එක එන්නේ මෙතන. x2 එක එන්නේ මෙතන. Okay? So what will happen is අපි ගන්නවානේ x1 minus x2 and y1 minus y2. හරිද? Let's say this is 0.98. හරිද? මම 1.1 ඉන්නවා. 1 2 ඉන්නවා. Okay. This is a huge difference නේද? Almost 0.14 millimeters of difference. Okay. If that difference is there, first thing you are going to check is whether it is coaxial. Second thing you are going to check is there are some places, okay, where it is fine if the capillary tube is coaxial, but මෙහෙම crack එකක් තියෙනවා. Okay. Then what can we do? මෙහෙම crack එකක් තියෙනවා නම් what can we do? Okay. You have to there will be certain dark region. හරි මෙහෙම dark region එකක් හැදෙනවා. Even though there is a crack. So we have to take it under that dark region. Okay. Then you will get almost similar values. Okay, next. That's an external way. මේක experiment කරනකොට තමයි තේරෙන්නේ. ඒවට RT20 paper එකද? මේක experiment කරනකොට you will find out. Next. You have to level the base. මේක දන්නවා. Okay, you have to use the spirit level to level the base. And in a traveling microscope, there is no zero error. Why? Even if we find a zero error, what will happen? How are we taking measurement? X2 minus x1. Okay. Even in this experiment, we are taking z minus x. Okay. So let's say it has a zero error and we call it R. Then we have x2 minus R minus x1 plus R. Okay, these two will get cancelled off. We are left with x2 minus x1. So finding the zero error is unnecessary. Okay, then? And then as usual, there's what you call there's you have to keep the percentage less than 1%. Therefore, the measurement should be greater than 1 millimeter. Due to optical inversion of the image, the observed field of view moves in the exact opposite direction of your physical adjustment. Therefore, to shift the image, when you are measuring left, you are actually measuring this side. If you are measuring right, you are measuring this side. So when you are moving from this side to this side, you have to actually move. When you are measuring from right to left, you have to move left to right. That's all. Then we have some other thing, some other special points when finding refractive index. First thing is z minus 8 divided by z minus 1. Okay. This value, it can be 1.2 or 0.9 centimeters. Okay. 1.2 or 0.9 centimeters. Okay. Or we can use something like 8 over 6 centimeters. 8 centimeters over 6 centimeters. Okay. Which one is more accurate? Which one is more accurate? Which one is more accurate? Because what will happen is, make up to 1.2 kilo and have the 1.2 kilo in yeah, 1.2 kilo in 2, 1, 5 kilo and then we are getting 9, 0, 1. Then make, when you divide these, there will be a huge difference from 4 over 3. 4 over 3 is a normal value. From that, there will be huge deviation. But let's say make this is going to be 8.052. Okay. And this is going to be 6.010. Now, if you divide these two, there won't be that much of a difference. Okay. There won't be that much of a difference because this is a larger value and this is smaller value. Okay. So it is better we keep the blocks in such a way that we use the maximum net, that we use the length of it. Breadth එක පාවිච්චි කරන්න height එක පාවිච්චි කරන්න. We have to use the length of it. So we have to place it such that we use the length of it to measure. Okay. But there's one more point. මේ glass block එකේ length එක හොයනවා කියලා කියමුකෝ. If this part is a cracked part, ඒ කියන්නේ මොකද්ද? When you cut it into pieces, when you cut glass blocks into pieces, let's say you have a huge glass block and then you have cut it into pieces. This piece won't be this piece won't be even. This space. So we cannot use this. Okay, we have to use a smooth, even face. So the image is hurried. Okay, so we have to consider that as well. Or cracks the end of along. If not, there might be like damage points like this. Name a damage point. Name a damage point. Can we use that side? No. Then we have to use some other different sides to find the main refractive index. Next thing, when you put a lycopodium powder, make a glass block surface now. We are putting lycopodium powder like this, okay? Okay? Conduct down. Okay, you don't put a huge mountain on top of it, then the reading is wrong. Okay? But what happens? Let's say you have accidentally filled on it. Take the cloth, wipe the whole thing off. Wipe the whole thing off and then put another layer of lower lycopodium powder. Okay? The calculated refractive index is always respective to air. Okay? Yeah, because we are taking a traveling microscope and a human to measure. Nitrogen environment next thing is we can use this for another modified experiment. Okay. Now we are finding glass refractive index of a glass block. What else can you find here by modifying the experiment a bit? Let's see if someone else answers. There's another name. What's the material? We can find the refractive index of what is that material? Oh, what is the type of the material? Yes, liquid. When we are using liquid, there should be two things. Liquid should be transparent or opaque. At least opaque, okay? So because the reason is basically if you have 30 centimeters of water, 30 centimeters of copper sulfate, you should be able to see the cross current experiment. Yeah, therefore it should be somewhat transparent. Okay, that is the main main thing we have to consider there. When we do that, okay, we can in a liquid also same thing, but instead of lycopodium powder, we use a powder that floats on water. Okay. When you are using a liquid, can you uh, make graph? And liquid you can change the Z by any amount. තව 10 මිලිලීටර් දැම්මම 1 cm උඩට යනවා. තව 10 මිලිලීටර් දැම්මම 1 cm උඩට යනවා. So we can find either and x. So එහෙම පුළුවන්ද? Can we draw a graph of liquids like that? Can we draw or not? Yes or no කියලා කියන්න බලමු. Yes or no? Can we draw a graph for නෑ මෙහෙම කියමුකෝ. මේක ඉන්න we have this. Can we draw a graph like this? මෙහෙම graph එකක් අදින්න පුළුවන් වෙයිද? Can we draw? Y equals mx graph එකක් අදින්න පුළුවන්ද? Simple question. Yes or no කියලා කියන්නකෝ මම කියන්නම් හරිද වැරදිද කියලා. අවුලක් නැහැ. You still have time for trial and error. Yes, no. Why? No, no. Why? Hey, what do we do to find it? We put something that floats on water. We put a powder that floats on water. Then after that, the water is completely covered, even an X and back. X is impossible to find. Therefore, we cannot draw a graph. ඒකත් මතක තියාගන්න because මේකත් මතක තියාගන්න ඕන දෙයක්. Yeah, we can. So in this last month, okay, you can upgrade by 1 with practice. Anyone, හරිද? ඒ කියන්නේ A, B, C, H, S මේකෙන් මේකට යන්න ඕන මේකෙන් මේකට යන්න ඕන මේකෙන් මේකට යන්න ඕන මේකෙන් මේකට යන්න ඕන. For all three, if you balance. Okay. එකක් විතර කරනවා නම් if you only studying one subject, then you can go from here to here. ලොකු jumps කරන්න පුළුවන් if you are studying only one subject. But තුනම balance කරනවා නම් you can go through one steps. You can go one step ahead. ඒක අවුලක් නැහැ. ඒක ගැන හිතන්න එපා. Now what you have to think is පුළුවන් තරම් ප්‍රශ්න කරනවා. I am doing as much as question as I can and I am scoring as much as I can. I am gonna score the most I can within this attempt. එහෙම හිතාගෙන you are gonna do. එච්චරයි. ඒක වෙනවා. That's a normal thing. In everyone's life, you cannot balance all three subjects. अरे එකක් අමතක වෙනවා. Okay. That's why you go for paper classes. When you go for paper classes, okay, if you're focusing on 2 subjects, you will be at 80 in 2 subjects, okay, and then 50 in another. Okay, and then you start studying this will go up to 80, and then this will drop to 4. When you have a paper class, you know. Oh my goodness. Make it where is it? Oh my god. Simplifying decimals. Decimals are going to ඒක වෙනවා. So what happens is that happens in a paper. මේක තමයි ඉවර ගන්නකෝ අමර වෙන්න කරන්නේ. Okay. But at the end of the day, okay, whatever the marks you have got in the paper, you are going to get a bit more than that. මම නම් අන්තිමට ගත්තේ නෑ මං ගැන කතා කරලා වැඩක් නෑ. It doesn't matter. මම ගැන කතා කරලා වැඩක් නැහැ. It doesn't even need. Anyhow, I know it just depends on the confidence, okay? I know a friend, one of my closest friends, okay? If I get 78, he'll get 75. Okay? Okay? But at the end of the day, because he lost confidence from the maths paper, we got BCC. එයාට 3 එක ගන්න පුළුවන් එක්කෙනෙක්. confidence එක ගියාම BCC වුණා. Okay, he's doing second year as well. Okay, so it mainly depends on confidence. Some people, I know a friend, I am not sure, I was not sure whether he will get this result as well. Okay, මේකත් ගණීති කියලා දන්නේ නැහැ. මේ sure නැතුව හිටියේ. But with some kind of confidence or something, he has got this result. Okay, මාත් ගන්නේ ටර්ම් ටෙස්ටිං එක මාරවලින් 10 20 30 කියලා. But at the end of the day, at the end of the exam, he has written for BBC. British Broadcasting Network මේක නෙමෙයි. Yes, that is my report. මගේ results ඕනේ. We are out of time as well, ne? What shall we do? Are we going to do the past paper question? Result එක ඕනේ කට්ටිය මේ ටිකක් දාන්න මම මේක දාන්න. නැත්නම් it would be like something like I would be boasting the YouTube channel. I did match team, okay? Okay, that was my result for the person who asked. Next, 2018 A-level. For the result, Kandy District 2015 for the result, okay? What else? 2018 A-level, okay? 2018 A-level was the last time from 1990, that was the only question we got from traveling microscope. Other question, okay? Otherwise, we had parts of it, okay? Here and there, 42 marks, 3 marks, otherwise, a full question came in 2018, okay? Identifying the parts. You know how to identify the parts, ne? A is going to be fine adjustment of vertical fine adjustment of function to make fine adjustments when taking vertical measurements. B can you focusing knob in order to move the microscope and focus on the object we are using. Okay, C. What is C? Leveling screw in order to level the traveling microscope bed of the traveling microscope. D. What is D? D හරි මේකේ D එක චුට්ටක් අවුල් ගිහලා තියෙන්නේ කමක් නැහැ මේ forget that question D එක because පින්තූරේ අවුල් ගිහලා තියෙන්නේ okay. Before starting the experiment, while familiarizing with the traveling microscope, a student observed that when the fine adjustment knob relevant to the horizontal movement was turned, the corresponding vernier scale did not move. What is the reason for it? What can be the reason for it? One thing, the lock screw is not tight enough. The lock screw isn't tightened. Okay. Therefore, yeah, that is the reason. They have given only one line. They have to write the reason within that line. The enlarged figure of the main scale and the vernier scale of traveling microscope are shown in the figure. Calculate the least count. What is the least count going to be? 0.01. You have 50 and then 0.5 millimeter divisions. What is the reason? What is the adjustment that you perform on the eyepiece before starting the experiment. What do we do? Uh, Time dah. What is the adjustment that you perform on the eyepiece before? Yes, focus the crosswire. Make cutting the appeal. Yeah. May it could be the horizontal binary scale. Yes. Spirit level maybe. Spirit level hammer spirit level is not in our syllabus. Okay. Lock screw if. Okay. Must be the what do you call horizontal vernier scale. Okay. Oh wait, I'll check and tell. What do you allow can give me a minute, okay? Mm-hmm. 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 2018. Um yeah, it was the spirit level, okay? Yeah. It is spirit level again. Why do we use the spirit level? To level the mhm, level the traveling microscope, bit of the traveling microscope. What is the adjustment that you perform in the eyepiece before starting the experiment? What is the adjustment that you perform in the eyepiece? We move the eyepiece such that the crosswires are focused. Next thing. Now you are asked to place the given piece of paper on stage G. And we started from traveling microscope question and we have ended up in refractive index of a glass block. Write down the main steps in. Write down the main steps in the experimental procedure you would follow to achieve this. What do we do? We normally unlock the microscope, okay, and adjust the microscope assembly until an image of X is seen. Then we use the focusing knob, okay, to get a focus of the image. Okay, focusing knob කියලා ලියන්න ඕනේ කියලා දීලා තිනවා. If you don't write, no marks. Okay. Next one. What is the reading? ඒක බලලා කියන්න බලමු. What is the reading? What is the reading? There. Set එකට දාන්න බලමු. Everyone has the tooth nail. Yes, for um the 4, 4, 1, 4, 2, 4, 3. 4, 3 to 4, 2. 4, 2, 4, 3 දෙකටම දෙන්න ඕනේ. හරිද? It looks the same. 4, 2 ට දෙන්නම්කෝ. 4, 2 ට දෙන්නම්. 4, 2 නෙමෙයි. It's going to be 4.692. A, 6.43 මොකක්ද? No, that's not how you take the measurement. First, we have to take the main scale reading. Main scale reading is the reading of the division just before the zero scale. Okay. ඊට පස්සේ then you have to add the vernier scale division. Okay, after taking the first measurement mentioned in E above, write down the important steps in the experimental procedure pertaining to the other two measurements. What is it? What do we do? We place the glass block on the X mark and take the relevant reading to when the image of the X is focused. Next, we sprinkle a small amount of lycopodium powder on the glass block and take the reading focusing on the lycopodium border. Then they have given you three values. Okay. You have to subtract it and get the answer. Can someone tell respectively what are the measurements? Again, 4.6016, 5.496 and 7.206. May XYZ is that what which is respectively right? What is may may comma XYZ taken by. How do you figure out? The highest value, the greatest value will be Z. The second greatest value will be Y. X එක අනිත් එක. Okay නේද? Do you have any doubts? If you are clear with the whole lesson and whole experiment and the what do you call a question, please put heart reaction. එකයි. හරි. Okay. Then that's it for today. From tomorrow onwards, today we have finished what you call measuring instruments. Tomorrow onwards, mechanics. Mechanics, how many experiments do we have? 1, 2, 3 and 4. So for next 4 days, mechanics. After that, light. Light is good at I have to the Okay. So that's it for today. Thank you very much. Good night.